All right, so for question number 3, again, we will first label our columns, X and Y, before we do anything else. Y, okay, now, whenever we have years for the data, make sure that you do the following. You never type in the actual year. Do not type in 1990 for your data set. 1990 would be year 0. So 1995 would be 5. And year 2000 would be 10, 15, 20, 25, 30. Okay. So the time or the X values here indicates how many years after or since 1990. Okay. Then you just go ahead and type in your 710 for your tuition cost. 1974, 2288, 2868, 4336, 5180, and 5717. All right, so make sure that all the numbers are typed in, and make sure you press enter for your last data point. And then ask yourself, do you know which key to go to, or what button to push to get to the scatter plot? You go home, and then the chart icon right here. Okay, so you have the scatter plot, but it's a mess because we haven't added the the variables yet. So you click on the axes, and you pair the horizontal axis with the X, and then the vertical axis with the Y. Then you see something like this. Now, the question would tell you what kind of relationship it is, because sometimes this one is like this one. It's kind of hard to tell whether it is a linear or exponential. For this one, it is exponential. So when you show your regression, which is to press menu, analyze, regression will show exponential. Okay. Where's the exponential? Right here, choice number 8. Okay. So in that case, the calculator will show you the exponential line of best fit, and also the equation, which you write down. You may round it to the 3rd decimal place. It tells you. It tells you, okay, whether it's exponential or linear. Now for college tuition, I wish it's linear, but unfortunately, it's been going up exponentially because they always say, all right, we're going to increase 5% every single time. And 5% every single time, it will end up to be an exponential function. All right, so you have this equation. You can write it down for your part A. Okay. And then we will copy the equation down, and this would also be the equation that we will use for our further analysis when we create a graph back at home. Okay. So again, you can round it to the 3rd decimal place or 3 decimal places. Okay. And then what do? You go home, and we will go ahead and create a graph right here. And we'll go ahead and type in our equation. So this is why you want to close up your document earlier, so that you don't confuse yourself with the points or with the functions. 1.07588. Okay, raised to the X power. All right, again, we have the same problem. We type in the equation and nothing's showing because our window size is not really helping us here. So I'm going to manually change it. Let's see how we can make sense with the data. So our X value goes from 0 to 30, right? So let's go ahead, go from 0 to 50, because we may have to project our future. And then my x values, ooh, where's my x? So my x values are 0 to 50 because we are projecting the future. And then the y maximum, I would say $6 would be pretty good, but that would not be the case. I'm going to project it to 10,000 because college tuition is pretty expensive. So this is how you decide your x and y values based on the meaning of the data. And once you do understand your meaning of the data, then you have a nice graph in front of you. Yes?
Y maximum is 10.
Y maximum, I wish not $10. Not $10. Oh, wait, hold on. I think this is not the right. Didn't type in the right.
It's 5,000.
Okay. So make sure you type in the equation properly. And now we can say which year would the tuition reach $6,500? That's your Y value. So go to tab. You type in 6,500. And then you have an intersection. You have an intersection, and therefore you can go ahead and say, all right, let me go ahead and analyze graph. Let me go ahead and analyze the intersection between the y equals to 6,500 and the exponential function. So it sets 28.2. So that means 28 years after 1990, which would be 2018. In the year 2018, according to the model, college tuition would cost $6,500 per semester, according to the model. Okay, so if that's 28.2, that is 28 years after 1990. Okay, so that's part B. 28 years after 1990, you will pay tuition at $6,500 per year. Okay. All right. Let me go ahead and remove the line so that you can see the picture better. For part C, it says if you go to college, if you're going to college in the year 2025, how many of you are going to college in year 2025? So you're sophomores, right? Okay. So so how much would you be paying? Well, 2025 is how many years from 1990? That'd be 35, right? So that means we know the x value. If we know the x value, we go to trace, graph trace. And then we type in 35, okay? Because we know the x value is 35. You type in 35. And then at the bottom of the screen, bottom right corner of the screen, you will see the answer. It sets 35, comma, 107 e plus 4. That means it's 1.07 times 10 to the fourth power. And that is $10,700 per semester. Well, fortunately, seems like that's not going to be the case for everyone here. But that's just for that's for UT Austin, right? Yeah, UT Austin. Well, that's not the case because I don't think it's that expensive at the moment. But it's just a matter of time that it will reach that price eventually. Okay, so that's how you use modeling to predict the future. Okay. And for part D, so if you finish your school in 8 semesters, then you basically just go ahead and multiply that number by 8 to get the total cost.